static electricity. Step 1. The leading cause of incidents in terminals involving a fire or explosion is static electricity. Static can be created in many ways, but in the fuel industry, it is most commonly created by the movement or friction produced between the product on the walls of a pipeline, a container, or a tanker compartment. Static occurs in our everyday operations, like when you are loading product into a tanker, draining product into a bucket, pouring product into a drainage tank, when removing clothing or simply wearing polyester or nylon clothing, and static can also be generated from a moving vehicle. Step 2. The way static electricity transfers or flows from one object to another is important to understand. When two objects have an uneven static electrical charge, it's known as an electrical potential difference between the two objects. When a connection is made between the two objects, the electrical charge will flow from one object to the other until the charge on each object is equal. Step 3. Static electricity is generated at increased levels when products that are poor conductors of static electricity are loaded. When filters are used in a pipeline, they generate higher levels of turbulence, and this creates higher friction, leading to a high buildup of static electricity. When faster loading rates are used, it increases the friction between the product and pipeline, creating a higher buildup of static electricity. If the product is contaminated or mixed with other materials or other products, these materials or products also create friction when they mix together during loading and increase the buildup of static electricity. If you splash fill product into a tanker compartment or a drainage container, the increased turbulence creates static electricity at a higher rate. Filling a container that's not connected with a static bond cable to a tanker or gantry will insulate the container and its product, not allowing the static electrical charge to equalize with the tanker or gantry. Plastic containers must never be used for draining tanker compartments. Plastic is an insulator, and if used, will build up a static charge and will retain that static electrical charge for a long period of time. Plastic containers are also likely to absorb the fuel they come in contact with and become soft or brittle and fail, causing a spill. Draining containers must be fitted with a static cable and the cable connected to the tanker when draining tanker compartments. If a static cable is not connected between the container and the container may build up a high static charge and retain that static charge for a long period of time. Step 4. Whenever static electricity is generated in a product or object, the static electricity will be attracted to any object that has a different electrical potential that is brought close to the static charge. Any object that attracts static is called a collector. Step 5. While all products produce static, some products are poor conductors of static electricity and produce more static electricity than others. Diesel, kerosene, jet fuel. Many chemicals and solvents do not allow static to disperse quickly, so static electricity builds up in these products more than products like unleaded and premium unleaded petrols. Step 6. Connecting the gantry overfill protection system to your tanker creates an electrical bond between your tanker and the gantry, allowing static electricity to equalize between the gantry and your tanker. The overfill protection system is a self-checking system and will only generate a green light to load if an electrical bond between your tanker and the gantry has been made. Static or bonding cables on containers require regular checking to ensure they are effective. Every time you use one, check for loose connections and faulty clips. Step 7. It is essential to ensure that all parts of the system, the tanker, the gantry, loading arms and containers for draining are static bonded at all times to minimize the buildup of static electricity and to assist with dispersing static electricity. Keeping all parts of the system bonded using static bonding cables ensures that they remain at the same electrical potential so that a spark cannot occur. Step 8. Product pumping speed influences the amount of static electricity generated due to friction in pipes, splash and turbulence in tanker compartments. When a tanker compartment is first being filled in a gantry, the pumping speed is kept low to ensure the product enters the compartment smoothly without splash. This ensures static generation is low. When product reaches a level in the compartment where it can no longer create a splash, the gantry system will increase the pumping rate to its full speed. Normal full-speed loading rate is limited to no more than 2,500 litres per minute. Step 9. One method of minimizing static is simply to allow time after loading is complete for any static charge to disperse. Once loading is completed, there is no requirement to open any part of the tanker. This will reduce the opportunity of introducing a static collector and creating a static charge spark.